Hello guys, welcome back to my YouTube channel. So today let's solve another LeetCode problem, which is search in a binary search tree. Okay, so let's start and let's understand what is the question given to us, and then we will write down the solution of it. So you are given a root of the binary search tree. So suppose will be a root of a binary tree, an integer value, a value of which you have to search in a binary that will be given. Find the node in the BST that the node value equals val and return the subtree rooted with that node. If such a node does not exist, return null. Suppose from here, this is the root. Okay, this is a binary tree. Okay, and the value to be searched is two. So from here we have to display this all values like 2, 1, 3 as our output. Okay. And if suppose the value is not present in the binary tree, then we have to output a empty list. Okay. Suppose here this was the binary tree and a value to be searched is 5. So 5 is not there in the binary tree, then we will output a empty list. So this is the problem which is given to us. So let's write down the solution of it. Define search EST, okay? And what will be our input parameter root will be there and value will be there, okay? On root, then return. Then if root is not there, then the output will be done, okay? This is the base case, and that will be if root dot val is equal to val. And if one more, if root dot val is less than val, means the value is greater than the root value. So it will be on the right hand side of the binary tree. Okay. You know how the binary tree is constructed. If binary tree the 4 is binary root is there, binary tree node. So 4 is there. So the number on the right hand side should be bigger than the root. And over here, this number will be less than the root. Here also you can see on the right hand side, the number which is there, 3 which is greater than 2, and but it is less than 4. So this is how the binary tree is constructed. And over here, there will be always number which is less than this number. Okay, but it will be not greater than 4 and not less than 2. It will be not greater than 4 and it will be between 2 and 4. Okay, for your also. So, so same example is there. So in the right hand side of the root, there will be always a number greater than the root value. Okay, and in the left hand side, the value will be less than the root value. Same way for each and every node, this rule will be followed over here also. If this 2 is there, so in the right hand side, always the value will be greater than this number. So this child value will be greater than this 2. So, but it will be less than 4, but greater than 2. Same way for this. This child value will be less than 2, but not greater than 4. Okay. So like this, the binary tree is constructed, and this is only the way that the binary tree is constructed. So if the value is less, root dot val is less. Means we have to see the value on the right hand side. Okay. So what we can do is we can return search VST root dot right comma where. Okay. We will search that node on the right hand side of the binary tree. That's what I have written. Else, if the value is less, then it is on the left hand side. So that's what I will be writing. Return search VST root dot root dot left comma where. So this will be the last condition. So by this we can easily find out our value in the binary search tree. I will run and show you. And let's see if there is some error, then I need to resolve it. Okay. I need to write in the class form. So that's what I will be doing right now. Class solution in like this. And your cell will come. And here also, where there is a function call, I have write cell. Okay. Now it should work for us because that what it was giving us error. It should be in a class form and now it is I have wrote down in the class form. So let's run and see if there is some error, then we will resolve it. So yeah, we have got the desired output. Now we have got the output, okay, and both the cases have been accepted. So yeah, this was the solution. So hope you guys understood the solution of this problem and very simple, and this problem was very easy also. If you will see over here, these problems come under easy, difficulty level is easy. So there was not something which is like you will not able to understand, but you will need to give some time to understand how the recursive function call work and how binary tree is values have been added and how the binary tree's values are given. On the right hand side, the value will be greater than the root, and in the left hand side, value will be less than the root. So that all you should know, and you should know the recursive and use recursive function, and you should know the class, how to define the class, how to add the functions in that. So that what it is. So I will now end up my video and hope you guys have liked my video and able to understand my solution. If yes, then please like, share and subscribe my channel and I will meet you in the next video. Till then, bye bye. Take care.